Many trips, so little time to think. Since my last one of these podcasts, I've made several trips. One was for a wedding, one was for a vacation, and following that, I went to San Diego for the Industry of Things World event put on by WeConnect of Berlin, who always puts on a really good Internet of Things conference, and this year was no exception. Had many interviews and met a lot of people there. Followed last week by going to Detroit for Siemens. Siemens has an event called Manufacturing in America, and that became 2 days for me. I went up on one day. I just drove up a couple hours to Detroit, whereupon I and five of my fellow journalists met with, actually first at a brewery where we saw Siemens equipment that helps brew beer, which is, I guess, fitting for a German company. And anyway, it was really good beer. It's called Founders Brewery, and had lunch then and went out to visit some students at Oakland University's Industrial and Systems Engineering Department. We met half a dozen students, and they're very enthusiastic, and it was very interesting. So, try to recap all these trips. Rather than chronological order, let's just take a look at, in the context of what we're calling right now digital transformation. It was digital factory and digital manufacturing and digital who knows what else. And in fact, I just got a press release from another company in England that's trying to put another spin on the word digital, which is all well and good. That's okay. Marketing people have to earn their keep, and but it's basically all the same thing, and it really kind of dates all the way back to cyber-physical systems, a paper that Dr. Touchard from National Instruments gave quite some time ago, and then some professors in Berlin, and I forget exactly which university right now off the top of my head. But the idea is that we have been dealing with physical objects, and now we can digitize so much that what we can do is have a digital representation of a physical object. We can play around with the digital representation before we, in the vernacular, in a previous life I had, cut steel, as we used to say, as it's time to cut steel and start building stuff. So, first off, and this is basically a stop with the students at Oakland University in Detroit. It's a Detroit suburb. It's not Oakland, California. It's Oakland Township. But be that as it may, let me back up just a second with the students. So for some time, we've gone under the impression that students viewed manufacturing and production as dirty, dangerous, not low paying, not challenging, not technical, and they would rather get their degree in computer science, go to Silicon Valley and build an app, and become wealthy, or go to Wall Street and do algorithms and stuff like that, and begin to make a fortune. And these kids that we met, and at my age I can call them kids, they were turned on by manufacturing. We met half a dozen. Half of them had fathers who worked in manufacturing, so they were well versed in what manufacturing was. And not only did that not deter them, it actually spurred them on to study engineering, to go into manufacturing and make it better. Why, you might say? Well, for one thing, over the last 20 years, I have seen such a fantastic change from when I went into plants in the early 90s to when I go into plants now. They're quieter because we now soundproof all the machining centers and so on. They're cleaner. We no longer let cutting fluids and machine oil run all over the floor and make it slippery and it's dirty and all that kind of stuff. It's brighter because we've put on in much better lighting now, and it's also not smoky in there anymore like it was from having open machines and machining and burning up all the machine oils and so on like that. We don't have little steel chips laying all over the place that collect in the sole of your shoe. Things are protected. So many safety things are in effect to make things safer. So much work has been done in lean and visual factory and things like that. In other words, it's a much more attractive place to work. And where these students saw it was it's an opportunity to make an impact right away. They can go in, they can solve problems, they can work with people, they can do engineering, and it's a challenge, and it's what they want to do. And they're very thrilled with it, and I think that's fantastic. So in the context of digital transformation, let me go on from there then. They're, of course, using Siemens equipment and tools because Siemens took us there. But let me go back to cyber-physical systems, and then the concept of a digital twin. The concept of a digital twin is that we have the digital representation of a physical thing. So it's a digital twin, if you will. Now, if I have a digital twin, I can do interesting things. So not only do I design in, say, Siemens PLM software and Teamcenter and so on, but I can also play with it. So part of their whole package is simulation. So these students do projects where perhaps they simulate a work cell, a person and a robot and an assembly or machining or something. And so they just naturally, by this point, because they've been taught, integrate lean thinking with these simulations and with making things better. So it's just a natural thing to just bring in lean concepts and into the digital twin and the manufacturing, and then work and solve a problem. And they all do projects that are hands-on projects just like this. They may get sent out to Fiat Chrysler or a local GM plant. The professor, Dr. Van Wil, talked about how some of the local places that are really challenging are hospitals. They have really terrible systems. And so they send these systems engineers out there and industrial engineers, and they're trained to look at things and look at from an industrial engineering point of view and also lean. And they actually go out and they're helping hospitals improve their processes. Some of them have actually been in operating rooms. One guy was in, and the surgeon said, "Oh, come on in to the operating room," and said, "Boy, it's a good thing I've got a good stomach because I don't think." He says, "Ah, come over here, look at this." So anyway, it's really interesting. I'm really jealous of these students that get to do all this kind of stuff. I was bummed out in engineering because I was already building electronic circuits in high school, and I go to college, and I would probably never get a chance to build an electronic circuit. And I thought, well, this is a waste of time. And being the typical rebel I was, I just got a degree in liberal arts, which, by the way, is very useful. So that's the first part of this. So digitalization, simulation, and so on, and these students, great experience, and so on. We had some really good speakers the next day at what they call the Manufacturing Summit or a Thought Leadership Summit at the Manufacturing in America conference and trade show. Several things were brought up, and it's really good. One of the more off-the-wall and interesting ones was a guy who spoke on blockchain and using blockchain technology. You may know blockchain because of Bitcoin. Two different things. Bitcoin is an application that runs on a blockchain, but he was talking about the use of blockchain in supply chain management. And blockchain is a technology that's a trusted, secure transfer of information. Let's just leave it at that, and you can go research it to your heart's content. I may be writing more on that in the future because it seems like more and more it's an accepted technology that's coming along. What I really liked was the presentation from a gentleman from KUKA, KUKA is a robotics company, and he's in charge of global PLM rollout. And so, of course, they use the Siemens PLM. That's why he's there. But he's using PLM from the standpoint of let's break company silos. So I have design engineers and application engineers and different people doing different kinds of systems. I've got different departments, different locations of the company around the world. And as I roll out my PLM, which is digitization, it helps me break the silos of the company down because we're all playing with the same digital representation. And so we can all talk the same thing. We don't have different things here, or throw this thing over the wall and let somebody else play with it, and so on. So, very interesting thing going on in PLM and digitalization, two different things. I digitize my product in CAD. I digitalize by using all this in my manufacturing. Moving on to another step in the Internet of Things, some things that are getting quite interesting are Edge. Edge has been there for a while. I have talked to both Dell Technologies and Hewlett-Packard Enterprise about their Edge. So they've taken some of their technologies like PC technology or server technology, packaged them a little differently, and could put them out on the edge. The edge is, I guess, edge of the network, but that's not exactly true, but sort of. It's sort of in between the sensor and the plant floor and the cloud, but it's closer to the plant floor, so it might be down there. And how we use it is we can, because there are these computer-based technologies, they can do a lot of things. They have a lot of storage. I can do a database there. I can do analytics there. I can do all kinds of stuff there. And maybe I can find out what's important and only send the important stuff up to the cloud, so I cut down my bandwidth. Imagine 50 billion devices, everything sending all its data to the cloud. Okay, we would choke. Our bandwidth would be like shot. Isn't going to happen. Forget it. So edge devices get to be very good that way. We're trying to do more computing at the edge, which is weird. It sounds a little bit like our old PC paradigm when I was younger. We got tired of the mainframe choking up everything, and that would be similar to the cloud if we could choke up everything. And so I do some more additional computing at the edge now, they call it, down in there. So I talked to Lynn Neese, a chief technologist for Internet of Things at HPE, and get a little more insight into all the things HPE can do with their edge computing and so on. Expect more on that. I'll be going to Hanover, and among the people I'm going to be talking with at Hanover would be HPE. Had a good chat with Jagannath Rao from Siemens. He's vice president in charge of, I think, executive vice president in charge of the Mindsphere group in Siemens industry in America. And Mindsphere has evolved from the time I first heard about it 2-3 years ago to where it is now. They're on version 3. Version 3 is actually a product. It's gone through several iterations as they've pretty much figured out what it is and how people will use it, which was actually more important. So version 2, they were still getting a lot of proof of concept requests, and now they pretty much know, and it's called an Internet of Things operating system or an Internet of Things platform. And one of the more interesting things about Siemens, so I already talked about Siemens on the PLM side. So if I look on the Internet of Things side with Mindsphere, 5 years ago, if I talk about Siemens and I mention open in the same breath, people would laugh at me. Siemens has transformed itself in many ways, and some of you will still laugh at me for saying that, but at the very least, they have transformed their language completely into openness. They've thoroughly embraced OPC UA, for example, an industry standard, without seemingly morphing it any and putting in little bits in there to make it work better for Siemens than other people's stuff or whatever. Common complaint that people have on big companies' adoption of standards. So at any rate, Siemens, Jagannath just over and over talked about open. We have open APIs. We allow open APIs. We've got Mindsphere. We encourage people. We want people to put apps on there and other things. Almost, not exactly, but almost like a store where somebody could put in an application and actually they could make money off of the whole Internet of Things in Siemens platform and so on. So watch for Mindsphere. I think it's found its place. I think they know where it is now. I think it's taken quite some time, but that's okay. Some of these technologies do take time. And I expect to see much more usefulness out of Internet of Things coming up. And I think especially paired with things like digital twin that I talked about earlier, digital thread, which is just the digital trail from the sensor to the, I don't know, somewhere along the supply chain or wherever. So I expect to see a lot more like that. And one last thing I'd like to talk about, just kind of wrapping up, there were several conversations about OPC and OPC UA at the Internet of Things or Industry of Things conference. And there's quite a German influence in the foundation right now, but lest anybody be misinformed by some of the presentations, OPC is not a German thing. The board of directors of the foundation is North American, European, German, and also Asian. And so it's an international, it's a global spec. It's recognized as the official specification for Industry 4.0 in Germany, but also in other places, France, China, smart manufacturing in the United States, all kinds of places. OPC UA is recognized as a standard. OPC UA is an information model. It is not a protocol. Some people get confused over what a protocol is and what a model is. So OPC UA models information, and it is such as it's a standard. So therefore, anybody who builds to the standard, an OPC UA information piece coming from one device to another OPC UA enabled device, they can talk to each other. It'll understand it. It'll recognize, the receiver will look and say, I recognize some of these bits and strings and so on. Oh, that's OPC UA. Okay, I know how to parse it out and use it as an information model. And that's an important thing to remember. Now, OPC UA needs a transport mechanism to get there, and so there are a bunch of transport mechanisms. There's AMQP, MQTT, which is getting a lot of press lately. Also DDS, which I can't say is popular, but it's popular in certain areas right now, like military especially. And so those are protocols upon which OPC UA can ride. Some people are starting to use a development from Cirrus Logic who has the MQTT protocol, and they've developed something called Sparkplug. Sparkplug is a little bit like kind of an OPC Lite. So it's a lightweight thing. You buy the tool from Cirrus Logic, but it's not real hard to use. The unfortunate thing about that is it's not an industry standard. Therefore, if you are a vendor and you're writing something in your device using Sparkplug over MQTT, you also have to write the thing at the other device at the other end of the transmission, because there is no standard. So it is what we would call a proprietary technology, and we'll see where that goes. I know by conversations that there are people who would like to see it become a standard. It would take a wide industry acceptance for that to happen, but I think it's a useful lightweight thing for sending messages within your own system if you're not having to go outside of your particular ecosystem of devices in your own company. So I've been a lot of places. There's a lot of stuff happening. This whole digital thing is for real now, as if it hadn't been already, but all the way from digital twin, cyber physical systems, if you will, Internet of Things is playing now, transmitting data from one thing to the next. So a lot of stuff happening. It's really cool, and glad to see things coming together. What I'd like to see now is it looks like there's been a period of consolidation, maybe a little bit more consolidation in a few places like software, but it looks like we're getting ripe for some small companies again. That's innovation often comes from the small company trying a new thing out. Eventually they sell it to the big company who incorporates it within their product maybe, and so on. So, Rick Bullata, where are you these days? After having just sold your last company. And so we'll see where all that goes. The innovation part of it is intriguing, And some of the innovation comes from end users who need to solve real problems and talk to their vendors and say, hey, I need this. And some of it's these small companies, guys get an idea and they go run with it and try it. And if it works out, sell your company for a nice little bit of money. So anyway, this has been Gary Minchell. We're talking digital twin and cyber-physical systems and Internet of Things and the hot topics going on right now in manufacturing and production.